Gentlemen, this is Miss Humbert here. Today we're going to be doing Unit 2 Learning Target 11 Notes. So we're going to be talking about solving systems using ending methods. So sometimes you're just given a system and you have to decide which method you're going to use and how you're going to go about doing it. So here's how you can kind of tell between the two. First, if it's solved for a variable. So if it's solved for a variable or it has a positive coefficient of 1, that is a great time to use substitution. Okay, when should we use elimination? Elimination is good if it's in standard form or if it has the same letter with the same coefficient. So those are good times to use elimination. So what we're going to do is we're going to go through a couple of systems problems and we're going to talk about the best way to solve this. So I see for number 1 that on the y's I already have opposite signs and it's in standard form. So I want to use elimination. So I need to ask myself, okay, what is the smallest number that 3 and 5 both multiply to? And that's going to be 15. So let's go ahead and let's take a look at number 3. So what we're going to do is we're going to multiply this one by 5 and this one by 3. So we're going to distribute the top by 5. So I'm going to get 5x plus 15y is equal to 80. Now notice when I distributed in the 5, I distributed all the way in. Okay? So then what we're going to do is distribute in the 3. So I get 9x, negative 5 times 3 is negative 15, and that's equal to negative 12. And now I'm going to go ahead and add down the columns. So 25x plus 9x is 34x. 15 minus 15 is going to cancel out. 80 minus 12 is 68. So then that 34 is being multiplied by the x. So I'm going to go ahead and divide both sides by 34. 68 divided by 34 is going to give me 2. So now I know that x is equal to 2. So where I see x there or there, I can plug in 2. Let's just plug it into the top one. So I have 5x plus 3y is equal to 16. So I take the x out and I put the 2 in instead. Plus 3y is equal to 16. 5 times 2 is 10. Plus 3y is equal to 16. Here, subtract 10 from both sides. Okay, so I have this 3y, and 16 minus 10 is going to give me 6. Divide both sides by 3, and I end up getting that y is equal to 2. So my x is equal to 2 and my y is equal to 2. So I'm going to write that out as a coordinate point. First my x and then my y. Well, number 3 to me is very obviously a elimination problem because it's in standard form and I already have same number, opposite signs. So actually it is already set up for elimination. So I can go ahead and just add down the columns. Well, 3x plus 2x is going to give me 5x. Negative 5y plus 5y is going to cancel out. 7 plus 13 is going to give me 20. So then I'm going to go ahead and divide both sides by 5, and I get that x is equal to 4. So then I'm going to take and I'm going to plug in x either there or there. So let's take it out of the first. So from the x, I can plug in 4 instead. Then minus 5y is equal to 7. So 3 times 4 is 12. Minus 5y is equal to 7. Subtract 12 from both sides. And then I get negative 5y is equal to negative 5. So then I'm going to divide negative 5 from both sides since that negative 5 is being multiplied by the y. And I get that y is equal to 1. So I'm going to write it out as my coordinate point. First my x and then my y. So the answer for number 2 is 4, 1. Taking a look at number 3. So for number 3, what I want to do is I want to write this out. It's already in standard form, and I want to write it out so that my x's and y's are together. Okay, so what I'm going to do is I'm going to flip these two around so that x is first and y is second. So I have 3x plus y is equal to 24. Then I have 5x minus y is equal to 8. Now I can go ahead and add down the columns because since I switched those around, my y's have opposite signs, okay? That's a good time to use elimination. So 3x plus 5x is going to give me 8x. Y plus a negative y, well, that's going to cancel out. 24 plus 8 is going to give me 32. Well, that 8 is being multiplied by the x, so I'm going to go ahead and divide both sides by 8. 8 divided by 32 is going to give me 4. So there I get that x is equal to 4. So I can substitute it back in for x in the first or the second equation. So let's go ahead. I'm just going to actually plug it back in to the first one. So that's 3x plus y is equal to 24. So I'm going to take my x out and I'm going to put 4 in instead. Then I have plus y is equal to 24. So then 3 times 4 is 12, plus y is equal to 24. Subtract 12 from both sides, and I get that y is equal to 12. Okay, so then my coordinate point is that x is equal to 4 and y is equal to 12. So that's my final answer for number 3. Taking a look at number 4, I see that it's already in standard form. Remember, standard form is ax plus by is equal to c. Well, whenever things are in standard form, that's when elimination is typically a good choice. So I see that I have a negative 1 on my y there. Okay, so then I'm taking a look at that 3y, and I'm asking myself, okay, what's the opposite of a 3y? And that's going to be a negative 3y. So then I ask myself, okay, what do I need to multiply a negative 1 by to get a negative 3? And I'm actually going to multiply it by 3. So I'm going to keep that top equation the same. Then I'm going to multiply the bottom equation by 3. 3 times 2x is 6x. 3 times negative 1 is negative 3y. And then 3 times 10 is 30. So now I'm going to go ahead and add down the columns. So then I get 5x plus 6x is 11x. 3y minus 3y cancels out. And 3 plus 30 is 33. That 11 is being multiplied by the x, so I'm going to go ahead and divide both sides by 3. And then I get that x is equal to 3. So x and 3 are the same thing. So where I see x in this original equation, either here, or you could even use that one if you want to, I'm going to plug in 3. So I'm going to take the equation 2x minus y is equal to 10. And I'm going to plug in, my 3. Okay, so then I'm going to do 2 times 3 minus y is equal to 10. So then I'm going to get 6 minus y is equal to 10. Well, that's a positive 6. So in order to get that positive 6 over to the other side, I need to subtract 6. So negative y is equal to 10 minus 6, which is 4. So then I'm going to go ahead and divide both sides by a negative 1. So then 4 divided by negative 1 is a negative 4. So then my answer is 3, negative 4. So write first my x, then my y in a coordinate point. So that's my final answer for number 4. Let's go ahead and let's take a look at number 5. So for number 5, I notice again that it's in standard form. So to me, it makes most sense to use elimination. So I see that my y's have opposite signs. So that means I need to multiply. Okay, so I need to get these two numbers to be the same. Well, the smallest thing that 3 and 4 multiply to is 12. So I'm going to multiply the top equation by 4, the bottom equation by 3. So when I multiply the top one by 4, I get 16x plus 12y is equal to 19 times 4, which is 76. 3 times 3 is 9x. 3 times negative 4 is negative 12. And then 8 times 3 is 24. So now I can go ahead and add down the columns. 16x plus 9x is 25x. Then we're going to take 12y minus 12y. Then 76 plus 24 is going to give me 100. So then that 25 is being multiplied by the x, so I'm going to go ahead and divide both sides by 25. That ends up giving me that x is equal to 4, and I can plug in x there or there. It doesn't matter which equation. I'm going to plug it into the top equation. So I have 4x plus 3y is equal to 19. So I'm going to take x out completely, and I'm going to put 4 in instead. Then add 3y, and that's equal to 19. 4 times 4 is 16, plus 3y is equal to 19. So then I'm going to take and I can subtract 16 minus 19. So I'm going to subtract 16, and then I get that 3y is equal to 3. Divide both sides by 3, and I get that y is equal to 1. So then x is equal to 4, y is equal to 1. Write it out as a coordinate point. First your x, and then your y. So let's take a look at number 6. So for number 6, I see that it's already solved for y. So since it's solved for a variable, to me it makes a lot of sense to use substitution. So y is equal to 4x plus 11. So where I see y in the second equation, I'm going to plug in 4x plus 11. So I have 3x minus 2, so I'm going to take the y out completely and put 4x plus 11 in instead. Now that's going to be equal to a negative 7. So now we're going to take that negative 2 and distribute it into both things in that parenthesis. Negative 2 times 4 is negative 8x. Negative 2 times 11 is negative 22, and that's equal to negative 7. So negative 3x minus 8x is negative 5x, minus 22 is equal to negative 7. So now what I'm going to do is I am going to add 22 to both sides. So then we get negative 5x, and that's going to be equal to negative 7 plus 22, which is 15. Then I'm going to divide both sides by a negative 5, and I end up getting that x is equal to a negative 3. So where I see x up top, I can plug it in here or here. Well, to me, it's smarter to plug it in that top one because I can plug in the negative 3 for the x. So I'm going to take the x out completely, and it's already solved for y, so that's going to make it really easy. Okay, so 4 times negative 3 is negative 12 plus 11, and negative 12 plus 11 is negative 1. So then I get that x is equal to negative 3 and y is equal to negative 1. So I'm going to write that out as a coordinate point with first my x and then my y. Taking a look now at number 7. So I see that number 7 is in standard form, which again indicates to me that I should use elimination. So I just need to go ahead and I need to figure out a way that I can get opposite signs. Because since the y's both have a negative 2, I'm going to multiply one of them by a negative 1. So then I have 5x minus 2y is equal to 12. That's going to stay the same. Then I'm going to multiply everything in the second equation by a negative. So everything is going to change signs. So 5x minus 3x, that's going to give me 2x. Negative 2y plus 2y is going to cancel out. 12 plus 2 is going to give me 14. So then I'm going to go ahead and divide both sides by 2. And then I get that x is equal to 7. Okay, so when I go ahead and do 7, what I am going to do is plug in. So I'm going to do 3, and I'm going to put 7 in instead. Minus 2y is equal to negative 2. So then 3 times 7 is going to be 21 minus 2y is equal to negative 2. Okay, so now this is a positive 21. So to get it over to the other side, I'm going to subtract 21. So I get negative 2y is equal to negative 23. Divide both sides by a negative 2. And when I do that, I end up getting that y is equal to 11.5. So now we're going to write that out as a coordinate point. First my x, and then my y. Next, let's take a look at number 8. Now, number 8 is definitely set up for elimination because I see that my y's already have same coefficient and it already has the opposite signs. So I can go ahead and add right down the columns right away because I already have those opposite signs. So 9x plus 4x is going to give me 13x. My 8y's are going to cancel because I have same number, opposite signs. 42 minus 16 is going to give me 26. So I'm going to divide both sides by 13, and I end up getting that x is equal to 2. So now I know that x is equal to 2, and I can plug it in for x there or there. So now I'm going to take the x out completely, and I'm going to put 2 in instead. Minus 8y is equal to 42. So 9 times 2 is 18, minus 8y is equal to 42. Subtract 18 from both sides, and I get a negative 8y is equal to 14 minus 18, which is 24. Divide both sides by a negative 8, and then I get that y is equal to negative 3. So then what we're going to do is we're going to put our x first and our y second. So we get 2, negative 3 for number 8. So taking a look at number 9. For number 9, I get that y is equal to 3x. So what I think is we should use substitution because it's already solved for a variable. Okay, so y is equal to 3x. So where I see y in the second equation, I'm going to plug in 3x. So I have 3x plus 4. Now instead of writing y, I'm going to write in that 3x instead. And that's equal to 30. So I have 3x plus 4 times 3 is 12x, and that's equal to 30. 3x plus 12x is 15x, and that's going to be equal to 30. So what I'm going to do next is I am going to divide both sides by 15. So then I get that x is equal to 2. So now that I know that x is equal to 2, I can plug it in for x in the original equation. So y is equal to 3, and instead of writing x, I'm going to write 2. And 3 times 2 is 6. So now we're going to write out that equation. First our x, then our y. So that is our final answer for number 9. Now, number 10, you could actually use substitution to solve. So you could use elimination, but I'm going to show you how you can use substitution if you like substitution. So what I'm going to do is I'm going to solve this equation for y, because it's pretty, or for x, sorry, because it's pretty easy to solve it for x. All I have to do is add y to both sides, and then I get that x is equal to y plus 2. So x is equal to y plus 2. So where I see x in the top equation, I can plug in y plus 2. So I'm going to take x out completely, and I'm going to plug y plus 2 in instead. Plus 3y is equal to 18. So now I'm going to take that 5y, and I'm going to distribute it in. 5 times y is 5y, 5 times 2 is 10, plus 3y is equal to 18. So 5y plus 3y, notice that they're on the same side. So that's going to be 8y plus 10 is equal to 18. Then I'm going to go ahead and subtract 10 from both sides. And when I do that, I end up getting 8y is equal to 8. Divide both sides by 8, and I get that y is equal to 1. So since I know that y is equal to 1, I'm actually going to plug it in for that y right there, because it's already solved for x. So then I'm going to end up getting that x is equal to 1 plus 2, which means that x is equal to 3. So now I'm going to write that out as a coordinate point. First my x, and then my y, which is 1. So I get the coordinate point 3, 1. So that concludes your note video for today. Thank you for listening.